Hello, I'm Lance Lamont, Principal Software Engineer for the Touchscreen Controllers Group, part of the Human-Machine Interface Division of Microchip Technology. This video will explore the primary types of analog resistive sensors and provide some information that may assist in determining the optimal sensor type for your application. There are three primary types of analog resistive sensors: 4-wire, 5-wire, and 8-wire. Each of the three sensor types has unique advantages. Microchip's touch controller options allow you to choose the best sensor for your application. Analog resistive sensors are constructed with three primary layers. The bottom layer is called the stable layer. The stable layer is typically a layer of glass to support the rest of the sensor. The second layer is made of spacer dots. The final, top layer, is called the flex layer. The flex layer is the one that is touched and is typically made out of polyester. One of the key advantages of an analog resistive sensor is that it allows activation by most any device, such as fingers, gloves, or stylus. Analog resistive sensors are activated by pressing the flex layer into contact with the stable layer. To determine the location of the contact, a voltage gradient is applied to one layer of the sensor. Then a voltage measurement is performed on the other layer of the sensor. As the location of the contact changes, the voltage detected changes, following the same principles of a voltage divider circuit. Now that we understand the basics of how all analog resistive sensors operate, let's look at the differences between 4, 5, and 8-wire sensors. A 4-wire sensor is the most basic and the lowest cost version of an analog resistive sensor. The sensor has solid bus bars on its four sides. The left and right bus bars are attached to one layer of the sensor, and the other two bus bars are attached to the other layer. Driving the sensor involves alternating which layer is the sense layer and which layer has the voltage gradient. An 8-wire sensor operates in the same manner as a 4-wire sensor, but adds a second connection to each bus bar. This allows an advanced controller to monitor the bus bar voltage and react to changes in the sensor. 8-wire sensors are preferred for scenarios that involve temperature and humidity changes. 5-wire sensors are driven differently than 4 and 8-wire sensors. These sensors use the flex layer as the sense layer and alternate both voltage gradients on the stable layer. This is done by driving each corner instead of the edges. By driving only the bottom layer, any damage to the top layer causes minimal changes to the coordinates decoded by the controller. 5-wire sensors are ideal for harsh environments where physical damage is a concern. Each of the three types of analog resistive sensors has unique advantages. 4-wire sensors are the lowest cost, 5-wire sensors are the most durable, and 8-wire sensors can compensate for thermal and environmental changes. For information on all of Microchip's touch controllers that universally support 4, 5, and 8-wire sensors, please visit the M-Touch Design Center at microchip.com/mtouch.